Okay, I just want to take a second and look at this question of the apparent motion of the sun. Why does the sun appear to be moving on our sky? Now, I'm not talking about just the daily motion of the sun, like where the sun rises and sets. What I'm talking about is the apparent motion of the sun over the course of an entire year. Why does the sun appear to be in different places in the sky with respect to the stars? Now, here's a familiar view of our solar system, sort of a top-down, I guess you could call it like a God view of the solar system, right? And we're watching the planets orbit around the sun, and of course the sun is not moving, right? It's stationary. So why does it appear to be moving? Well, we're on this moving planet here. So what I'm going to do is zoom in and see it from Earth's perspective, and we'll take a look at the sun from that rotating platform. So here's the Earth, right? And of course we're looking at the Earth. I want to change my perspective and look at the sun. So now as we look from the Earth at the sun, we see, right, we're getting this kind of perspective here where the sun is going around, where the Earth is going around the sun, but because our perspective is moving, we see what we appear to see is that the sun is moving with respect to the stars. So I'm watching the stars go to the right, right, as the sun goes to the left. So the sun appears to be moving with respect to all these stars. Now it takes the Earth 1 year to go all the way around the sun. So from sort of start to finish of where we see the sun with the same stars in the background here, the same stars right next to the sun, it would be 1 year later that we would see the same stars back behind the sun. Now we can see this a couple different ways. One way is by looking at this little simulation. From this perspective here we have the Earth in the center, and we can kind of simulate here where the sun would be located for different times of the year. So I can do that by sort of moving this calendar around on the bottom, right? I can start in January. I see the sun is located right here, and it tells me what constellation, what stars I see the sun next to. In this case, it's in the constellation Sagittarius. A little while later, I see the sun in Capricorn. Right? And I go a little further and I see it in Aquarius, Pisces, and you might recognize the names of these constellations, right? These are the constellations that make up the zodiac. And of course that's why the zodiac has significance, is that those are the constellations the sun passes through in its apparent motion throughout the year. This line on the sky, I mean, you're seeing a portion of the celestial sphere here, right? But you can imagine this whole celestial sphere going all the way around the Earth. This path that the sun follows we call the ecliptic, the path of the sun throughout the year. Another way to see this is with real astronomical data, right? We have telescopes that are continuously looking at the sun. One of them is a space telescope, and it's called SOHO. And it's taking continuous images of the sun, but of course the sun is so bright that we can't actually take pictures of the sun always. They're more interested, this particular spacecraft, among other things, is looking at the corona of the sun, the outer layers of the sun. So I want to show this to you, this little video, right, which is a series of images that are sort of played together. Now what you're seeing here, this little white circle in the center actually is where the sun is. It's being blocked out by what's called a coronagraph. It's basically just like a black disk that's blocking the sun so that we can see these outer layers. What I want you to pay attention to, though, are the stars. You'll see a lot of white specks in the background. This bright speck is actually a planet. But you'll see these bright specks in the background, and you're going to see all this stuff flying off the sun. We'll learn more about this stuff later, sort of coronal mass ejections that are going out. But I want you to pay attention to are the stars that you see in the background. So you're seeing lots of things happen. But one of the things you're noticing, I hope, is that the sun as a whole here in the middle is moving again to the left with respect to all these stars. In fact, you can even see a little cluster of stars drifting by. So this is a very real apparent motion we see in the sky. When you hear the word apparent, you shouldn't think like fake, right? It's our perception because we're on this moving platform. So I hope that makes a little more sense. I just wanted to show you those simulations and videos.